Hello, welcome everyone to this lesson. Today we're going to be talking about ranking. In this section, we're still focusing on describing dataset. Let's go ahead and read the learning objective. The first learning objective is to be able to interpret percentiles using the context of the situation. The second objective is to find the 5 numbers summary when given a data set. The next learning objective is to determine if a data set contains an outlier using the interquartile range, which is known as the IQR. The last learning objective is to be able to construct and interpret box plots given a dataset. Let's go ahead and start by talking about percentiles. In statistics, ranking refers to the position of a data value within a sorted list. In our case, we're going to take our dataset and we're going to order the dataset from smallest to largest. When we talk about ranking, we are referring to the position of one of the data values within our list. A percentile is a measure of ranking. A percentile is a number where a certain percentage of scores fall below that number. So let's go ahead and look at some examples to help you understand percentiles and to help you practice how to interpret percentiles. In exercise number 1, we're going to interpret percentiles using the context of the situation. So in part A, we're being told that let's start with part A. The 80th percentile weight of newborn babies is approximately 8 pounds. In other words, we're being told that 8 pounds corresponds to the 80th percentile. This means that 80% of newborn babies weigh less than 8 pounds. So again, if 8 pounds is the 80th percentile, this means that 80% of the data values, in this case, the data values are weights of new babies, 80% of those values are less than 8 pounds. A percentile is a number where a certain percent of scores fall below that value. Okay? Now I'm going to let you do part B on your own. In part B, you're told that the 50th percentile height for adult women is around 5 feet 4 inches. In other words, 5 feet 4 inches corresponds to the 50th percentile. I'm going to include a multiple choice question below this video to help you interpret this percentile. Now that we understand percentiles and what they represent, let's go ahead and talk about 5 number summary. Once we talk about 5 number summary, we're also going to talk about box plots. In statistics, we have special percentiles, which are called quartiles. We have 3 of them. If you calculate these quartiles together with the maximum and minimum, you have 5 numbers, which are known as the 5 number summary. Here, we're talking about the minimum, the maximum, and 3 special percentiles, which are called the quartiles. Let's start with the minimum. The minimum is the smallest data value in the data set. The maximum is the largest data value on your data set. Now let's talk about the first quartile. The first quartile is denoted as Q1, and 25% of the data values fall below the first quartile. So for example, if I tell you that x equal to 5 represents the first quartile, then you know that 25% of the data values fall below x equal to 5. Next, we have the median. This is the midpoint of the data. This is also known as the second quartile, but in practice, we call it the median. This is going to be the midpoint of our data set. We know that 50% of the data values fall below the median. The last special quartile that we have is the third quartile. This number is denoted as Q3, and 75% of the data values fall below the third quartile. Now, one thing that I do want to emphasize is that the first quartile, the median, and the third quartile are just special percentiles. We know that below Q1, we have 25% of the data values. That means that Q1 is the 25th percentile. We know that below the median, we have 50% of the data values. That means that the median is the 50th percentile. Below Q3, we have 75% of the data values. That means that Q3 is the 75th percentile. So again, Q1, the median, and Q3 are just special percentiles. Now that you're familiar with the 5-number summary, let's go ahead and talk about box plots. A box plot, also called a box and whisker plot, gives you a good graphical image of the concentration of the data using the 5-number summary. When you look at a box plot, you should be able to see the minimum, the maximum, Q1, the median, and Q3. If you have the 5-number summary, you should be able to create a box. We're going to look at an example where we're given a box plot. We're going to start by highlighting the key features of a box plot. The box plot that we have here below represents the data of the heights of 100 male semi-professional soccer players. Here the heights are given in inches, rounded to the nearest half inch. Here on the box plot, we see a number line. The number line goes from 59 to 75. We see that there's a title for the number line. Box plots are going to have a number line. They're going to have a title for the number line. The title here is player height in inches. If I look at the value 65, with the help of the title, I can see that 65 represents the height of one of the players. Same thing with 72. 72 represents the height of one of the players. Now, above the number line, that is where we see the box. So one of the common mistakes that I see when students are creating box plots is students placing the box plot on top of the number line. They make it look something like this. If you place the box plot on top of the number line, it's hard to read the numbers on the number line. Okay? So make sure that when you're creating box plots, you're placing the box above the number line, not on top of it. The last thing that I want to highlight here is that there's a title for the whole plot. The title here is Height of Semi-Professional Soccer Player. Let's go ahead and focus on labeling the 5-number summary values on the box plot. That is what we're being asked to do in part A. Here in the box plot, you can see the minimum. The minimum here is 60. You can also see the maximum. The maximum is 74. Q1 is going to be the value where the box starts. So here, the box starts at 66. This is the value of Q1. Now, where the box ends, that is the value of Q3. Q3 here is around 69.5. The last thing we're going to see on the scatter plot is a dash line. The dash line is going to be at the median. Here the median is around, I'm just going to say 67.5. Maybe it's a little bit less than 67.5. Again, I'm just going to go ahead and write 67.5. Now, one thing to mention is that it is sometimes possible to have the median be the same value as Q1 or be the same value as Q3. So it is possible to have Q1 and the median overlap. Same thing with the median and Q3. They might be overlapping. Now here's a question for you. What percent of data values do we have between the minimum and Q1? We have 25% of the data values between the minimum and Q1. Remember, Q1 is the 25th percentile. Below 67, we have 25% of the data values. Now, how many data values do you have between the minimum and the median? I hope your answer was 50%, right? Because below the median, we have 50% of the data values. How many data values do you have between Q1 and the median? Your answer should be 25%. Notice, between the median and Q1, we have 25%. Between Q1 and the median, we have another 25%. If we add those values, we get 50. That makes sense because 50% of the data values are below the median. One thing to emphasize here is that we see that between the minimum and Q1, we have a bigger spread than the spread we have between Q1 and the median. The data values between the minimum and Q1, they're more spread out than the values we have between Q1 and the median. The values that we have between Q1 and the median, they're less spread out. Okay? So that is why Q1 and the median are closer to each other. It doesn't mean that we have more data values between the minimum and Q1 and less data values between Q1 and the median. One more thing that I'm going to highlight is that we have 25% of the data values between the median and Q3, and we have 25% between Q3 and the maximum. Now I'm going to stop here and I'm going to let you answer part B, C, and D. Can you write a sentence using the context of the situation that interprets the first quartile? Here, the first quartile is equal to 66 inches. What does that represent? What percent of data values are below the median? And what percent of data values are between Q1 and the maximum value?